Now, a bar chart is used to display discrete data. And you remember from the collecting data unit that that is data where only particular values can be chosen. Now, when constructing a bar chart, you must remember these important things. All the bars must have the same width. You must label both the axes correctly. And you must also leave gaps between the bars. So if we look at some types of bar charts here, our first one is a vertical bar chart. You can see here it's about the favourite flavour of crisps. Gaps between the bars, all the bars are the same width, and we've labelled everything nice and clearly. Now, bar charts can also come in horizontal form as well. The frequency is now on the bottom instead of the vertical axis. Now, the rules apply exactly the same for horizontal as they do for vertical. Bars must be the same width, and you must leave gaps between them. Final bar chart we need to look at is a dual bar chart. Now, this is where, in this example, we can compare two different students' results across 3 subjects by plotting each individual's bar for certain subjects next to each other. The bars are of course the same width again, and there are gaps between the different subjects, but what a dual bar chart does is it allows us to compare between 2 or more people within a certain characteristic. Let's look at now pie charts. Our pie chart presents data in different sectors of a circle, as you well know. So for example, here in an eye colour pie chart, we would have that particular sector in blue representing the students with blue eyes, the red section representing hazel, green section representing people with green eyes, and the purple section representing those students with brown eyes. And each sector within that pie chart is calculated specifically on how many people within the total have each certain characteristic. Now, when we're calculating the size of each of those sectors, we must remember that there are 360 degrees in every circle. So in this example, if they want us to construct a pie chart for the following data about children's pets, they tell us here that 24 people have a cat, 18 have a dog, 8 people have fish, and 10 people have no pets at all. So when it comes to constructing a pie chart for this particular data, we must first of all work out how many students we have, in this case 60. Now that means that 360 degrees divided by those 60 students gives us an answer of 6 degrees for each student we have. So if we know next that 24 students have a cat, that's going to correspond to 24 lots of 6 degrees, 144 degrees. 18 students had a dog, so therefore again 18 multiplied by 6 gives us 108 degrees. And you can see we worked it out exactly the same way for fish and those people who had no pets by multiplying the number of students by that magic 6 degree number. So we now have all of our angles here, 144, 108, 48 and 60, and we can now plot that on a pie chart using our protractor. So what we're going to do now is have a look at how we would plot that pie chart onto our graph paper. So I'm now drawing the pie chart for that data that we just saw on the pets that people own. Now we've worked out what the angles were. Remember, we worked out that one person was worth 6 degrees and then multiplied the number of people who had each pet by 6. So our cat was 144 degrees. The number of people who owned that pet represents 144 degrees on my pie chart. So if we take a look at what I've done so far, I've drawn my circle. Now my centre point is there, and the first thing I need to do is draw a straight line from the centre to the circumference of the circle, like so, and that's where we're going to start measuring round from. So using our protractor, the first thing we're going to do is to measure that 144 degrees that represent the cat owners. So make sure we've got our origin lined up with the centre of the circle, and that up here, 0 is on that first line that we've drawn. And then we're going to count round using the outer dial all the way round to 144. So there's 140, 4 extra marks from there. We draw a little mark like so, so that when we take the protractor away, we can see where we join the centre to that circumference again. And then joining up the centre to the circumference, making sure we go through that mark that we just did, we've just drawn an angle of 144 degrees. And we can label it as that's the proportion of people who own a cat. Now we're going to do the same for the dog owners. Now they had an angle of 108 degrees. So bring the protractor round, remember centre on the origin, and make sure that 0 is in line with the line you've just drawn, and measure using the outside again, 108 degrees. So here's 100, and add count 8 on from there, and put our little mark, and then do exactly as we did before. Join the centre to the circumference, making sure it goes through that mark, and that is the 108 degrees that represents the dog owners. Next one we'll do are those people who have fish as pets, and they had an angle of 48 degrees. Once again, centre point there, 0 on that line we've just drawn, count around to 48, which is here, put the little mark, and then join them up as before. And then we can label that as the people who own fish. Now the final one we don't actually have to plot because it's what's left on our pie chart, and it's for those people who had no pets at all. So we can label it, but it's always worthwhile checking to see if it is indeed the right size, and we can do that just by putting the centre on there, lining 0 up to the line we've just drawn, and you can see that back up at that original line we drew measures 60 degrees. So we know we've plotted all of those angles correctly. Now, if we look at how to interpret a pie chart, well, let's take a look at this one here. It tells us that 120 students were asked what their favourite sport was, and the pie chart given here shows us those results. So it tells us athletics was 105 degrees out of that 360, swimming was 120, and so on. Now, when they give you a pie chart in this form, it usually means they're going to be asking you to work backwards and find out how many people each angle represents. Because remember, the 105 there doesn't necessarily represent 105 people, as only 120 were asked in total. What they're asking us is which sport was the least popular, what fraction of students liked athletics, and how many students liked tennis. If we take a look back, which sport was the least popular? Well, we look back at which one has the smallest sector within that pie chart. And the smallest one here is that green one, which represents tennis. So therefore, tennis would be our least popular sport. It then says, what fraction of students liked athletics? So if we go back to our pie chart, we can see that the students who liked athletics, that was 105 degrees. And that's 105 degrees out of the 360 degrees. So if we were to write that as a fraction, 105 over 360, you can then write that in its simplest form. You'd come up with the answer 7 over 24. Now the last question said how many students liked tennis? Well, we know from our pie chart that 36 degrees made up those students who liked tennis, and that's 36 out of the 360 degrees. Now if we write that as a fraction, 36 over 360 simplifies to 1 over 10. So in other words, 1/10 of the students liked tennis. Now 1/10, remember in total we asked 120 students, so 1/10 of that number gives us 12. So in other words, 12 students liked tennis. The next way of presenting data we're going to look at is line graphs. Now, they're usually representative of the results that have been recorded over a period of time. So for example, in this line graph, you can see we've recorded the temperature over a period from 12 AM to 9 PM. And what the line graph does is it shows us the rise and fall of that temperature over time. The next one we're going to look at is histograms. Now, histograms are similar to bar charts, but we use histograms for continuous data, which you'll remember is data that can be measured. And so there are no gaps between the bars in histograms. If we take a look at this first example, it tells us that the time taken to carry out a task was recorded for 30 people, and the results are shown as follows. So between 5 and 10 seconds, there were 3 people, 10 to 15, there were 5 people, and so on. So we're going to plot a histogram for this data. And you can see here, our histogram is essentially exactly the same format as a bar chart. Notice here we start at 5, which was the lower end of our first class interval. And we have equal class intervals, 5 to 10, 10 to 15, and so on. And that's why there's no gaps between the bars, because 5 to 10 goes straight on to the bar with 10 to 15. Now, if we wanted to construct a frequency polygon, which is another way of presenting data, all we need to do is, using that histogram, mark the midpoint on each bar and then join those points together with a straight line. Here's a question that's going to give us the histogram already plotted and ask us to interpret some results based on it. So this histogram shows us the marks scored in a test by a group of children. Now the questions are, how many children sat the test? Well, we can calculate that by looking at each bar and working out the total of each bar and adding them together. So 4 plus 6 plus 11 plus 12 plus 9 gives us 42 children in total sitting that test. It then says what was the modal class. Now you should remember from the work on averages that the mode is the most common, or the one with the highest frequency. So if we look at our histogram, the bar that has the highest frequency is that 4th bar along, which is representative of the class 20 to 25.